Hello everyone. Welcome back to our channel. If you guys are new on this channel, please subscribe to Constro Talks. So let's start the video. Today, we will see what are the different tests carried out on concrete and is its significance. So let's go. So testing concrete is essential to ensure its quality and durability. Here are some common tests carried out on concrete. Slump test measures the workability of fresh concrete. Significance ensures the concrete can be properly placed and compacted. Now we will see the procedure. During slump test, following steps are followed. First of all, the internal surface of the mold is cleaned and free from moisture and free from other old sets of concrete. Then place the mold on the smooth horizontal, rigid, and non-absorbent surface. The mold is then filled with fresh concrete in 4 layers with taping each layer 25 times by taping rod, and level the top surface with a trowel. Then the mold is slowly pulled in vertical and removed from concrete so as not to disturb the concrete cone. This free concrete deform all the surface to subside due to the effect of gravity. That subsidence of concrete in the periphery is a slump of concrete. The height difference between the height of subsidence concrete and mold cone in mm is slump value of concrete. So there are 3 types of slump we get. First one is true slump. True shape of a slump is only a verified slump. This shape is measured as the difference between the top layer of the cone to the top of the slump concrete. Second one is collapse slump. It shows that due to a high water-cement ratio, the shape of a slump is not a clear dimension. It means concrete is very high workability, for which slump test is not suitable. And third one is shear slump. This shape of slump is the same as shear failure of soil. This is an indication of a lack of cohesion of the concrete mix ingredients. So, a fresh sample is taken and the test is repeated. Compression test determines the concrete's strength by subjecting it to axial loads. Significance ensures the concrete can support structural loads. The apparatus we use in this test is compression testing machine. Procedure for concrete cube test. Remove the specimen from the water after specified curing time and wipe out excess water from the surface. Take the dimension of the specimen to the nearest 0.2 m. Clean the bearing surface of the testing machine. Place the specimen in the machine in such a manner that the load shall be applied to the opposite sides of the cube cast. Align the specimen centrally on the base plate of the machine. Rotate the movable portion gently by hand so that it touches the top surface of the specimen. Apply the load gradually without shock and continuously at the rate of 140 kg/cm to minute till the specimen fails. Record the maximum load and note any unusual features in the type of failure. As a result, for 7 days of cube have to gain 65% of strength. For 14 days, 90%, and for 28 days, 99% strength should be gained by cube. Now we will see flexural strength test. It measures the concrete's ability to resist bending forces. Significance, crucial for assessing its suitability for applications like beams and slabs. In this we use flexure strength testing machines are designed to test flexural strength of concrete beams. Density test measures the density of hardened concrete. Significance indicates its resistance to cracking and durability. Water penetration test evaluates the concrete's resistance to water infiltration. Significance helps assess its durability in wet environments. Chloride ion content test measures the presence of chloride ions, which can cause corrosion. Significance ensures the concrete's long-term durability especially in coastal areas. Alkali-silica reactivity test detects potential reactions between alkalis in concrete and reactive aggregates. Significance: prevents cracking and deterioration due to alkali aggregate reactions. Permeability test measures how easily liquids can penetrate the concrete. Significance: helps assess its resistance to chemical attacks and freeze-thaw cycles. Air content test determines the percentage of air voids in concrete. Significance: ensures proper freeze-thaw resistance in cold climates. Maturity testing monitors the concrete's curing process by measuring temperature and time. In this test, we can also use sensors which placed in beam, slab or column while concreting. This sensor connected with Wi-Fi, so they give the temperature and time data. From that data they also give the maturity of the concrete. I hope this video will help you to understand the various tests carried out on concrete.